First, let's look at 3 stacked books. This is one of those problems that give a lot of students a headache. A person pushes the bottom book to the right, and all 3 books move together. Let's find the direction of the friction forces. We'll start with the top book. The top book is only in contact with the middle book, so the friction force on this top book comes from that contact. Now ask yourself, how would the top book move relative to this middle one, or tend to move relative to the middle book? Since the books are moving together, there's no relative motion between them. So we need to look at the tendency of relative motion. Imagine the friction between the top and middle books suddenly disappears. The middle book would move forward with the bottom book, while the top one would tend to stay where it is because of inertia. So relative to the middle book, the top book would tend to slide backward. To oppose that tendency, the friction force on the top book points to the opposite direction, which is to the right. Now let's move to the middle book. This is where the problem becomes more interesting. The middle book is in contact with 2 different books, the top book above it and the bottom book below it. That means the middle book has 2 different friction forces, and we need to analyze each contact separately. First, let's look at the contact with the bottom book. Imagine the friction between the middle and bottom books suddenly disappears. The bottom book is being pushed to the right, while the middle book would tend to stay behind. So, relative to the bottom book, the middle book would tend to slide backward. So the friction force on the middle book points to the right. Now look at the other contact, the one between the middle and top books. We already found that the friction force on the top book points to the right. But this time, we are looking at the friction force on the middle book, from the middle book's point of view. So let's use the same method again. Imagine the friction between the middle and top books suddenly disappears. The middle book would move forward, while the top book would tend to stay behind. So, relative to the top book, the middle book would tend to slide forward. To oppose that tendency, the friction force on the middle book points to the left. Notice something important here. The middle book is moving to the right, but one friction force on it points to the right, and the other points to the left. So simply knowing which way the middle book is moving tells us nothing about the direction of either friction force. We had to look at each contact separately and ask, how would the 2 objects at that contact move relative to each other, or tend to move relative to each other? That's what determines the direction of friction. And there's one more important point. At the same contact, the relative motion depends on which object you are analyzing. If we are analyzing the top book, we ask, how would the top book move relative to the middle book, or tend to move relative to it? If we are analyzing the middle book, we ask, how would the middle book move relative to the top book, or tend to move relative to it? Same contact, but a different object of interest. Now let's look at the bottom book. The bottom book also has 2 contacts, the middle book above it and the table underneath it. Let's analyze the contact between the bottom and middle books first. We're looking for the friction force on the bottom book. So again, imagine the friction between these 2 books suddenly disappears. Relative to the middle book, the bottom book would tend to slide forward. To oppose that tendency of relative motion, the friction on the bottom book points to the left. Now let's look at the contact between the bottom book and the table. In this case, the bottom book is actually moving forward relative to the table. So the friction force from the table opposes that relative motion. Therefore, the friction force from the table on the bottom book points to the left. So the bottom book has 2 friction forces, and in this case, they both point to the left.